Welcome back to episode 2. In our previous episode, we discussed the essential functional and non-functional requirements for our LRU cache. Now let's deep dive deeper into the design. We'll explore the high-level architecture and examine some key data flow sequences. To follow along and access the full code, please visit the GitHub link provided in the description. Now let's start with the high-level design. Just generally speaking, we have a client, and the client is going to invoke our APIs that's offered by the DsikLRU cache. This is the central component that manages the overall cache. It acts as a gateway between the client and the underlying memory and disk-based caches. There are several other components in our DsikLRU cache. The first one being the memory LRU. This is a traditional LRU which is implemented in memory. It stores the frequently accessed data for quick retrieval. Then is a DsikLRU, a persistent cache that stores data on disk. It's used to store data that doesn't fit in the memory cache or for data that needs to be persisted across application restarts. Finally, a lot of our persistence will be backed up by journaling, a log file that records the sequence of cache operations, the writes, reads, and deletes. It's used to maintain consistency and recover the cache state in case of a crash or unexpected shutdown. The cache files is where we will store most of our data and we store on the file system. So the general flow will be the client requesting for some data that is stored in the cache. Our DsikLRU cache will first check the memory LRU to see if the data is present. If it is, it will return those bytes. If not, it's going to ask the DsikLRU to load the data from the disk. And the DsikLRU, once it returns back the bytes, that will be loaded into the memory LRU and will return back to the client. The key points of our architecture is that the journal is used for ensuring data consistency and recoverability. The DsikLRU cache acts as a layer of abstraction and provides a unified interface for clients to interact with both the memory and disk-based caches. The LRU eviction policy in both the memory and LRU cache are coordinated such that we comply with the constraints provided by the developer or by the client. Now let's describe the sequence for a cache miss. The client sends a request to the DsikLRU cache to fetch data with a specific key. This component checks the in-memory LRU cache to see if the key exists. If the key does not exist, it will check with the DsikLRU to see if the key exists. And if the key exists, it will return back bytes, but since this is the first time, the key won't obviously exist and will return a null to the client. Then the next sequence, we can talk about the store. This is when the client has fetched the data from a URL or somewhere else further away from the client and provides the byte array to the DsikLRU cache. So once that is done, the DsikLRU cache will actually just store these bytes in memory and will return back the result to the client with a success. Now we outline the steps involved in a flush operation. The flush process involves synchronizing the in-memory cache with the on-disk cache to prevent any data loss. The first step in the process is when the client requests a flush operation. A background task is created and it's run by the DsikLRU cache to flush all the data asynchronously, preventing the main thread from blocking. All entries stored in the in-memory LRU cache are retrieved. For each entry, if the entry has been modified, it's updated and is written to the on-disk LRU cache. If the entry has been deleted, its corresponding file is removed from the on-disk LRU cache. We employ the concept of journaling throughout this process. A journal entry is recorded to document the transaction. The journal entry is crucial for recovery purposes, allowing the cache to be restored to a consistent state in case of a crash. The transaction is marked as complete in the journal once the operation is completed on disk and the client is finally notified. This sequence illustrates the steps involved when a cache hit occurs in a DsikLRU cache for the first time. First, the client sends a request to fetch data with a specific key. We check the in-memory LRU cache to see if the key exists. The in-memory LRU responds to the request, indicating that the key does not exist. We then check the on-disk LRU cache to see if the key exists. The on-disk LRU responds, indicating that the key does exist. And hence, now we load the key pair from the on-disk LRU cache into memory. Finally, we update the timestamp that the key was retrieved and we return that to the client. This sequence diagram now illustrates the steps involved when a subsequent cache hit occurs in the DsikLRU cache. This means data was previously loaded into the in-memory cache. So when we find it in the in-memory LRU cache, we respond with the bytes that are already in the cache, but we also update the last access time. Now this last access time gets reflected in the DsikLRU when the flush is called. Okay, now it's important to discuss the journaling that we are going to add to this cache. It's a vital mechanism in the cache for ensuring data consistency and recoverability. It acts as a log that records a sequence of cache operations, allowing the cache to be restored to a consistent state in case of a crash or unexpected shutdown. Our journal file has a bunch of journal entries. Each entry in the journal represents a cache operation. It typically contains whether the operation is an update or a delete, a transaction ID, the key of the cache entry, and the timestamp. So the flush operation triggers the journaling process, in which the cache starts iterating over the in-memory cache entries. For each entry that needs to be updated or deleted, a journal entry is written to the journal file. The entry contains the operation type, transaction ID, key, and timestamp. Finally, the update or delete is done on the disk, and then a commit is issued, which is marked into the journal for a successful transaction. So we need this during the recovery process, where when the cache is initiated, it actually goes over these entries and then removes the incomplete entries. And in that way, we are able to recover from a crash situation, and our journaling works. Thank you for watching so far. And now we will dive into the code for most of this.